Hello there, and welcome to everyone joining us for this latest IoT Central webinar. I'm Clive Maxfield, everyone calls me Max, and I'll be your host. In addition to being a practicing engineer myself, I also act as a technology consultant, author, speaker, and educator. I'd like to start our webinar by thanking Arduino Pro for sponsoring today's event. Arduino Pro is a leading supporter of the IoT Central community, and we're very grateful to have them as sponsors. Today's webinar is entitled Arduino Portenta X8, Superpower Your Linux Applications with Real-Time Execution. Before we begin, I'd like to briefly review the format of today's proceedings. This whole event will be 1 hour long. We'll have one presenter who I'll introduce in just a moment. And I'd like you to feel free to ask questions at any time during the presentation using the questions feature in the control panel. And we're going to have a Q&A session after the main presentation. So now I'm very pleased to introduce today's speaker. Andrea Richetta is the head of customer success at Arduino Pro. So Andrea, whenever you're ready, you can take it away.
Hello, Max. Thanks. Hello, everyone. Thanks for having me today. My name is Andrea Richetta, and I work every day with companies to help them find the right way to integrate the Arduino Pro technology into their business. Today, without any further ado, I would start with my presentation. And I would like to give you an introduction of Arduino and Arduino Pro. Then we will go through a technology overview of the X8. And I will show you a short demo that I prepared for you. And then at the end, as Max said, we will have a Q&A session. So let's start. And let's go with an introduction of Arduino. So Arduino started in 2005 with this mission: enable anyone to innovate by creating complex technology, open and simple to use. So we started with the Uno, that probably is the board that you already know. It's well worldwide known. And during the year, we designed many boards, tools, software in order to create a complete ecosystem of tools and sets in order to let people innovate without asking permission. So making complex technologies open, so open source and simple to use. During the year, we specialized and our organization into 3 business units that basically are aligned with the market. So everything starts with the Arduino education, where learn by doing is the mantra. We do provide the kids tools, products, both for students and not only for students, but also for teachers, for letting them to find the right way to teach technology to the students. So we have a lot of products in that field. Then during the year, we moved and we created the business unit of the makers. The makers is the bigger one. Makers are hobbyists. Makers are every age, sorry, and they innovate and they find creative solution for everyday challenges. So we saw, you know, and you saw probably a lot of different things, great stuff created by this amazing community. At the end, so finally, we create the Pro business unit. So within the idea of continue to create astonishing things, we want to provide the same experience to the company. So we want to enable business transformation with the same philosophy, so with the same idea of keeping everything simple, open, And so in that case, the companies can leverage the same philosophy that we have. Thinking about manufacturing, because everything starts from the hardware, 100% of our boards are manufactured in Italy. We have different OEMs, we have different SMT lines, but one thing, high quality standards for an individual product testing and dedicated support suppliers for product assembly. Because you know that every single market, every single segment, schools, makers, and companies have different needs. So for thinking about the products, we have dedicated lines with a higher testing and higher grade components for our boards. Some numbers. You know, we have a really big community. Probably is one of the biggest in the world. But just to give you an idea, our IDE, so the tool that is used for programming our board, not only our boards, but of course, every single piece of Arduino hardware is downloaded more or less 40 million times in a year. And we have something like two times year over year. Then we have more than 1.6, now I think that we are 1.8 million of users of our Arduino IoT Cloud. And then during the video, during the demo, I will give you a sneak preview. And then we have more than 4,000 officially library reported, meaning that I would say that for each sensor in the market, probably you will find an Arduino library. So if you Google the sensor, probably you will find a ready-made Arduino library ready to be used. Which is, so to give you an example, which is our end-to-end offering. So we said that we want to keep it simple, we want to keep it open, and so how it works basically. So we provide different steps. Hardware at first, so boards, kits, solutions, from prototyping to production. This is really important, because if a company wants to start a new project, iterate, test the idea, test the business opportunity there, so they can start using one of our products designed for companies in a pro space, and they don't have to change during the stages. So they can start prototyping the idea. So think about a project that needs different kind of components, so they can choose the right board, and then the same board goes into production, because they don't have to change at some point the board for going to production. And this is what it means. Basically, that the fast time to market, no need of changing, so no R&D time lose for moving and learn another board. So everything can be used from the prototyping, so from the start of the project to the deployment, the mass deployment in the market. Then we provide development tools. So you know, hardware is important, but having a right software that makes this hardware working great is another big responsibility. So we have code generators, we have a lot of examples, we have compilers, we have debuggers, we have the IDE, we have CLI, we have a lot of tools, and of course we have also cloud and on-premises editors. But moving forward, we have introduced the cloud services. As I said, we have right now around 1.8 million of users in our cloud. So with the same philosophy of low code, or at least no code, you can connect the board in a very clever manner. With 3 clicks, we do provide everything that is needed for taking the board and connect it online in a secure way. We'll talk about later of this. And we do provide web and mobile UI. We have a nice app that you can download on your mobile phone. And we have device management. We have full APIs for connecting and federate our cloud to any existing cloud or service, external service. And then the knowledge. Knowledge is another important, paramount importance pillar for us. So we have the community, we have the content, we have support, and everything under open source umbrella. So the companies can leverage the same hundreds of millions of code that is already there for their needs. So this is, really a game changer, because, everything now, open sourcing things, it's all it's secure, and it's a proven way to continue to innovate in a faster way. So I stop here and I ask for the first poll before we start. So my question is, before registering to the event, were you familiar with Arduino Pro? This is interesting, and I like, to have this interaction with you, because it can be useful for me to continue with the presentation. So I would like to, if you were familiar with Arduino Pro or Arduino and Arduino Pro, or not familiar at all. So it would be really interesting to understand your knowledge. Okay, some more second, and then we will reveal the answers. Okay, great. So I was familiar with Arduino, but not Arduino Pro. It's 76%, right? Good. And I was familiar with Arduino Pro, 25%. Great. So for the 20% that was not familiar with Arduino and Arduino Pro, welcome in our family. Okay, moving forward, which is the Arduino Pro mission. We want to disrupt the way of IoT and AI at the edge are adopted by enterprises. How we can do that? We can do it in several ways, but I summarize into these three pillars: democratize and simplify the access to technology. So broaden the developers that are, beyond the specialized engineer, reducing friction for adoption, and make it easy for people that don't know Arduino Pro, our products, our boards, our tools. It's the right way, and it's the most efficient way to enter into this world. So starting from a project, starting from an idea, iterating and test it, find the right, commercial framework that works for the company. And in the meantime, behind that, there's a lot of companies, a lot of users that every day works and publish codes that it's ready to be used. This is the right way to promote technology. So innovation without asking permission. The second one is end-to-end human-centric hardware and cloud platform. Again, reducing complexity of putting everything together. So I have a board, I would like to connect, I would like to send data in a easiest way, in a fastest way. So I like to say that all the things or the products or the cloud should be easy for beginners and fast for professionals. So if you don't know what are you doing, there's a lot of guidance that let you go and create your project. But at the same time, if you know what you are doing, you need to find a fast way, to proceed, and having everything under control. So this is really important. And the last one is open source. I know that I turn back and back on this concept, but open source, it's really the key for leveraging this larger developer community and knowledge. Think about sharing and knowledge for fostering the adoption and reduce lock-in risk. You know that no one wants to be locked into technology, in a board, in a hardware, because at some point they will feel stressed. So we don't want to lock in everyone. We want to let the people have the freedom to choose the right technology for their need. And so you can buy our boards. You can use it with whatever ID you want, with whatever language you want. You can use it with our board with Python. You can use our board with C++. You can, or whatever you want. You can use with tool set, different tool chains, ID. So whatever you want. You can use your own board with our IDs. You can use our cloud with different boards. So as you can see, there's a lot of combination that can be done, and this is the way for people to start. If I have a board that I know and I want to connect to Arduino IoT Cloud, that's a problem. There's no problem for that. I have a Arduino board and I want to connect to AWS or another cloud. Perfect, no problem. There's no lock-in. We do provide everything that is needed for connecting to your preferred cloud. So again, think about open source, think about no lock-in, innovate without asking permission. But let's talk about now the Portenta X8. The Portenta X8 is our latest product announced 1 month ago. It's a powerful industrial grade system on module that has Linux and Arduino in a separate cores on the same board. So it means that on the Linux side, it's capable of running device independent software thanks to its modular container architecture, and of course provides the best approach for the two worlds: the flexibility of Linux combined with real-time application that you can reach using Arduino environment. And the board has Wi-Fi, so you can perform OS and application OTAs updates in a secure way. Let's have a brief overview. So it's two industrial grade products in one. I said that we have two separate microprocessor, microcontroller. So on the Linux side, we have an Nxp MX8 Mini with a quad-core A53 microprocessor with up to 1.8 gigahertz per core. And then on the other side, we have the STM32H747 with a dual-core microcontroller M7 plus M4. So that's plenty of power inside this board. The Portenta X8, it's plug and play. You can experiment right out the box because we provide a Linux OS based on Yocto distribution that is installed and ready to be used. On the container side, we provide this experience. So you have the BSP, and then on top of that, you have the containers that can be used. And then one other important pillar, security. Every connected product, Arduino, is secure by design. So we don't have any board that is connected that it's unsecure. We have for each one a secure element right on the board in order to keep the security at the highest level possible. So in this case, for the X8, we thought that not only is important to have the secure hardware, but of course also providing a secure environment. So you don't have to hustle, you don't have to keep the security by yourself, because we provide, by subscribing to our Arduino Cloud plan made for the X8, you can have a continuously updated Linux environment, and you can have also the secure deployment of your containers. Everything starts from the crypto chip, and this is possible by leveraging the best-in-class Nxp Secure element that we have. An overview of target customers. So when it comes to performing real-time and high-performance image processing on the edge, so think about security cameras, security traffic monitoring, license plate management, so parking into the building automation, or if you need to implement Linux-based multi-protocol gateway solution, then you can use it, the Portenta X8 for creating some industrial or smart railways gateway. Or if you need to implement some secure kiosk or digital signage project, we have a full HD display out of the Portenta X8 that can be used for smart vending, interactive kiosk, smart lockers, and of course, you can use it for local user interaction, connecting a small HD monitor local. So you can also use with the touchscreen, whatever you need. And then, of course, implement Industry 4.0 capabilities on any industrial equipment. So upgrade obsolescence industrial computer system, obsolete industrial system, so retrofit any system machine, implement security compliance devices, or having an advanced data logger. In some way, I will show you later in the demo. Example, condition monitoring for predictive maintenance purposes, and all-in-one HMI and control device locally. One interesting thing about the X8 that is ARM system ready, IR certified, means that this system ready is a certification issued by ARM that basically certifies that on top of the board, without changing the operating system that we provide, you can also run your preferred Linux distribution. In this case, you can run Fedora IoT 35, Fedora Server, and Debian. And of course, based on Linux microplatform LNP v85. Another achievement that is really important, and it's, back to the security, is the board is level 1 PSA certified. The PSA is an organization made by big brands, and basically stands for platform security architecture. So starting with the silicon, with a root of trust, around that creating a system software that leverage the root of trust, and of course we have a product and device with a root of trust. So everything is connected, everything is tied together in order to create and have a secure product in the field. So you can, by having this certification, you can meet regional and regulatory for cybersecurity requirements. We do provide a secure bootloader, secure update, anti-rollback system. So there's no way to roll back the software and find some bugs or a security hole. It has unique identification, and of course, it's isolation and secure interaction for of the services. So this is another great achievement for the board that is available out of the box. But again, on the security, we are quite obsessed by security. So we provide end-to-end security. As I said, on the hardware standpoint, we have the secure element, but we have also provided crypto library. In this case, for the X8, we are using OPT, that it's a small operating system that is born for interacting only with secure elements in order to abstract the security complexity. You can just interact with OPT, and then OPT will take care of everything that is needed for storing certificates, challenge, create random number for handshaking. On the other side, for the Linux, for the Arduino core, we have the embed STM on the STM core. So we have Linux operating system, we have embed operating system on the microcontroller. Regarding the cloud security, so the end-to-end security starts from the ground, goes to the cloud, and we have confidentiality with TLS, mutual authentication, and two-factor authentication for our accounts. We do provide secure OTA updates and automated provisioning. So let's go in deep into the technical specification. The board, as you can see, it's quite dense, and from the top we have the Wi-Fi and Bluetooth Low Energy chip. Then we have 2 GB of low power DRAM. Then we have the first beast, the Nxp IMX8 Mini. They said it's quad core up to 1.8 gigahertz. We have the power manager with power delivery. So USB-C, we do provide also power delivery. And there's a chip dedicated for powering all the rails that are needed. There are many that are needed for the board. And then we have an high-speed USB-C connector, the first one on Arduino boards, that also provide DisplayPort output and can act as host or device operation. On the bottom of the board, we have the MCU, so the STM32H47. It's 480 to 40 megahertz. Then we have the Nxp Edgelog SE0650 for Nxp, the secure element. And then we have gigabit Ethernet PHY for giving Ethernet connectivity through an external control. And then 16 gigabytes of flash memory. As for other Portenta boards, we have here 2 high-density connectors. So there's 160 signals coming out from these 2 high-density connectors. So we do provide for external connection CAN, PCI Express, audio interfaces, video interfaces, SPI, and of course I2C and I2S communication. So here on the hardware side, there's really plenty of opportunity for create project and expand capabilities. Regarding containers, short idea on how it works. So as I said, we provided this experience with the containers. So on the lower side, you can see there's the hardware, so the board. On top of that, we have the secure Linux operating system. And then on top of the operating system, we have the virtualization layer. That is, in this case, it's Docker. So on top of the Linux operating system, we have Docker running apps. So on a container-based system, you can deploy your apps and create device-independent software. So you can start building your application even on your PC, on your Mac, and then you can cross-compile for the board, and then you can push the application running directly on the board. So seamlessly, you can have your application running on your computer, and then you can push it on the board itself. So if you are not familiar with the containers, so this is a really short introduction. So which is the differences? Probably you know what are virtual machines and versus containers. So virtual machine, it's basically a pile where the infrastructure on the lower side is made by hardware. Then on top of that, we have the hypervisor. And then we have single different operating systems that are divided and are isolated. So for each of this, you have your guest OS, you have your bins, your libs that are needed, your drivers, and the apps. And this happens for each operating system you want to run on the hypervisor. On the container, this is slightly different because with the same infrastructure, so you imagine this, the X8, we have then on top of that the operating system, and then we have the container engine. So in this case, as I said, we have Docker. But on top of this, you don't have to have a single operating system. So you have just only to pack the images, so your bins, your libs, and your application. You can build your container and you can run. So the container engine will handle all the operations that are needed to keep it isolated and secure. So in our case, the Portenta X8 will act as a Docker host. So you can see here the Docker daemon and all the containers. So each container is isolated and runs one or different images based on your application. Of course, as we are using Docker, that it's well known, you can go and use our images that we provide. You can use Docker application. You can create your own, so customize your application and develop and deploy on the board. So you have the freedom to choice. If you have, for example, you want to run Alpine, this is a small operating system that is quite useful and quite used on the microcontrollers. You can download it. You can download the image of Alpine, add your applications, add your driver, build a container, and run on the X8. So it's really, really useful. So as I said, for having the board secured and having the Linux distribution securely maintained, you can deploy and update application packages into container. We create the Arduino Pro plan factory bundle. So it's a subscription for giving you the best experience when it comes to get pre-installed Python containers, other Arduino containers that will be made during the time, from time to time, get individual provisioning keys. So again, you will have single provisioning keys to keep your application secure while massively deployed in the field. And then secure OTA updates, not only for your containers, so not only for application standpoint, but for security and operating system based updates. So for your device and fleets, so your fleet management will be really easy to maintain and to be secure over time. Let's see some application examples into the industrial automation. You can think the X8 as a good companion for a connected edge computer for manufacturing, for example. So combining the Portenta X8, the Portenta Max carrier, and the X8 becomes a powerful Linux computer capable of controlling sophisticated industrial equipment. You can get environmental data from remote node sensors, and this is shown in demo, and then do data data logger, and then you can send data whatever you want, wherever you want in a cloud. You can use it for autonomous guided vehicles. You know, ROS stands for Robot Operating System. There's a container that it can be used for on your Portenta X8, and so in this case, by leveraging the dual core, the dual heart of the X8, so the Linux side and the Arduino side, you can build your AGV, you can use your autonomous guided vehicles, interfacing with cameras, lidars, motor wheels, batteries, and so on. Into another field of applications on the building automation, we can have an example on AI analytics, for example, for offices and factories. So you can interact with environmental smart sensors. You can, add ML, machine learning, and AI activities on the edge. So you can monitor how many incidents or control access reserved areas are sending alerts in real time. That you can use for smart kiosk, based on peripheral PC with a lot of computing power, and you can furthermore use it for a smart kiosk and connecting security cameras, microphones, or any kind of diverse selection of IOs. You know that to Arduino, standard Arduino, you can connect keypads, you can connect sensors, peers, or whatever sensor you want. So you can have the best of both worlds. And then moving on the office and house control system, the X8 can simultaneously control HVAC systems, switches, control on and off accesses on edge. Last one in smart agriculture, so you can have an help for supervised navigation and control for mobile farming. So adding the GPS connectivity, you can track your tractor in the field in order to have a proper crop yield. So now let's talk about related products. I mentioned many times the Portenta Max Carrier, but we have also the Portenta Cat M1 and narrowband, so giving another opportunity of connectivity. The Portenta Vision Shield that adds camera and microphone, and for the Portenta Breakout for giving some help during the initial stages of the projects. When it comes to the Portenta Max Carrier, just quite a small overview. It's a powerful carrier exposing the main Portenta peripherals. So you have a CAN RS-45, 3232, 485, USB, mini PCI Express. You can expand your project, adding multiple connectivity options, Ethernet, LoRa, Cat M1, narrowband IoT that are on the board. So it has micro SD and featuring integrated audio jacks and battery backup. So you can see here, there's the nice thing. Here's the slot for the X8. And as you can see, it's quite dense, but you have LoRa, so with dedicated antenna, cellular dedicated antenna for narrowband and Cat M1. And then the nice thing is that you can use the mini PCI Express to connect card for other kind of purposes. If you need to add another connectivity option, or you need to add some external memory. So this can be used for using any external device. Okay, stop now for another 30 seconds. I hope that you're enjoying this webinar, and so start the second poll. You know which kind of project are you currently working on or you are preparing for. So some project into building automation or industrial automation or agriculture or agritech. We are seeing a lot of different projects going on, so also into the agritech field or other project types. Or you simply don't have any kind of project ongoing. This could be interesting. Some more seconds or let you reply. In the meantime, I get some water and now see results. Cool. So industrial automation, It's the first one. And building automation. Okay, good. 6% agriculture and other project types. Nice. So for the 20% that don't have project now, I hope that I give you some idea on your next project. Cool. So we are almost at the end of presentation. So a few words on our co-marketing partners, ARM, Nxp, and Foundries.io. ARM provided, we are long-term friends with ARM people, and we are long-term friends with Nxp that provided the microcontroller, the microprocessor running the Linux side. And then welcome to Foundries.io that provides everything that is needed for the security and for the operating system that is running on the board. A small wrap of what you will find with Arduino Pro. You will find documentation. If you have any question needs for documentation, you can find on docs.arduino.cc, getting started, datasheet, libraries, user manuals for each of our product. Of course, we have community, as I said. You can go and find probably an answer to your question in our forum. If you need some training, just head over to our contact us form for your question, and we will happy to support with also some customized training for you. We have generic support. Anything that doesn't work happens, but we are here to help. We have a help center. So for your FAQs, I would say we have a nice help center with hundreds of thousands of answers to questions. And of course, again, navigate to docs.arduino.cc to find tutorials and examples, chat sheets, getting started manuals, everything that is needed for your out-of-the-box experience, starting from the board and going forward. Now it's demo time. Few words about this demo. I will be using, as you saw, and you will see in the recorded video, an MKR Maker Wi-Fi 1010 plus the MKR M Shield for getting environmental data, temperature, humidity, sending them to the Portenta X8 via wireless. And on the Portenta X8, there's a container running InfluxDB that it's well-known time series database, so use it for pushing into a lot of data and then representing on a time scale. And we manipulate a little bit the data with Node-RED, that is another app that is running on the same container. And then I will show how it's easy to create a dashboard and sending data from the X8 to the Arduino IoT Cloud. Okay, let's start. Here we are. For this demo, I will use a Maker Wi-Fi 1010 connected via wireless. And on top of that, the M Shield, capturing the humidity and temperature. The data will be sent to the Portenta X8, shown here, mounted on a Portenta Max carrier. As you can see on the Portenta X8, there's a container running a video output showing the capabilities of the video and GPU. And on it, we have another container running an instance of Grafana and Node-RED. So let's start from the sketch. The sketch is quite simple, and here I am including the Maker Env library. I'm using the Arduino HTTP connection for sending data to the X8, so it's a standard HTTP. Here I set the InfluxDB token here's the bucket and the IP address of the X8 plus the port, so 8086. And here I install and initialize the maker env. Down below, I will start to compose the string to be sent to the X8. So in this case, I'm sending the device name, the SSID, allocation, the Wi-Fi SSI, and temperature and humidity. So from the sketch standpoint, this is everything I need to send. It's quite straightforward. So now the sketch is running, and from the serial monitor, I can see the data that are sent to the InfluxDB database. Here we have the console of the InfluxDB. So this is the IP address of the X8. So port 8086. Now I'm navigate to the Explore. So here I can see that the InfluxDB version is 2.20, and going to Explore, we will see that here in this window, I can see the bucket, I can see the environment and Wi-Fi status, so the filter that I set, and humidity, temperature, and RSSI. Now I run this query, and I can see the data displayed in real time. Looking at the data, you can see the differences, and seeing that now we are storing them into InfluxDB locally. In this page, I can see the query that can be useful for sending this query from a remote system. Now I have here the Node-RED instance. So this again, I'm on the X8, and this is a simple flow for getting data from the InfluxDB from Node-RED and then sent to the Arduino IoT Cloud. Here is the node of the InfluxDB. I can now get the humidity and the temperature using the query that I showed before. I can take this payload, that is the data value, and this value is sent from the InfluxDB through Node-RED to our Arduino IoT Cloud. So going into cloud.arduino.cc, I can access my cloud panel. So I click on IoT Cloud, that will bring me to my personal window with all the things that I have created. So now I have created this demo X8 remote that basically contains all the variables that I want to get. In this case, I'm getting humidity and temperature. And now let's create a dashboard together to show, for example, the humidity. So I click on Create. This will bring me to the dashboard creation panel. So I name this dashboard as a demo X8. And now I add some widget to my panel. So scrolling down, we can see different kind of widgets that can be created, and I pick up the chart widget. This is the window of the chart widget. I name it with the measurement that I want to display, so humidity. I link the variable that I want to show. I'm taking from the things, demo X8 remote, and I click on humidity. So I can see a brief overview, and then I can link them. Now, clicking done, everything is set up. So I can start to see the data coming from the X8. So this is an example on how it's easy without any kind of coding to show data from Arduino IoT Cloud, or different kind of data coming from boards, coming from external services. And this is a way really fast to interact with the object. So thanks for watching. Okay, cool. Okay, so now it's time for a Q&A session. So I would invite back Max. Eccolo, hi back. Hi Max. I talk in Italian, so Max.
Buongiorno.
Great.
Well, thanks so much, Andrea. That was very interesting. I'd just like to tell our audience, I think we're going to run a bit late because we've got so many questions coming in. So let's say that we're going to run over by 5 to 10 minutes. And I think we still won't have a chance to answer all the questions. But I didn't want to rush things and say, well, that's it. Thanks so much. Goodbye. So we'll just talk until it's time to stop. Any questions that we don't answer now, Andrea will email those people and give them the answers later. I was going to say it's very interesting that you made the point right at the beginning that a lot of people think about Arduino only in the context of hobbyists and makers. And that's certainly the way it started out, of course, back in 2005 and so on. But I know a lot of professional engineers who use Arduinos, even if they're using the hobbyist versions, they use them to evaluate sensors and things that they then put in professional products. And now that you've got the Arduino Pro processors like the X8, which is mind-blowingly powerful, they are starting to appear all over the place in professional systems. I'm going to cheat and start with one question of my own. Before this presentation, I did go on the Arduino website and looked up the X8. And all over the page, it says 9 cores, 9 cores, 9 cores. And so we've got the Nxp chip, and that's got a quad core, A53, so that's 4, and a Cortex M4, so that's 5. And then we've got the ST micro chip with a dual core, 6, 7, and a Cortex M4, 8. So either I'm losing the ability to count, or there's a missing core. Where is that missing core, Andrea?
You are right. And every time sometimes ask me this question that it's absolutely legit, I would ask my colleague from the marketing team to send the answer. So in this case, the missing core is on the wireless chip. So the chip itself, it's dual core.
Okay.
And so that's, on a marketing standpoint, it says 9 core, but available for the users, yeah, you're right. So we have 4 core on the 853 and 2 cores on the Cortex M7 and the M4. Technically speaking, the M7 is a candidate for keeping the connection between the 2 cores, but I don't want to spoil anything if there are any questions.
Okay, now we do actually have quite a few questions. I'm going to gather some of these together. So one is, how do the 2 processor cores, how do the 2 processor chips on the X8 talk together? And I did wonder if there was like a remote procedure call type mechanism or something. Another one is, can the Linux part communicate, so that would be the Nxp chip, communicate to the MCU part, that would be the ST micro chip, and update the code? And then another one, can the STM, the ST micro chip, run with the NXP turned down? So I imagine that means turned off or asleep. And then can the ST micro chip start the NXP chip, the Linux. And a use case will be real-time control of a sensor in the STM chip while the Linux core is shut down to reduce power. And then when certain conditions are met, the STM detects and boots the Linux to respond. Take it away.
Okay, great. So great questions. Thanks for answering. So yeah, starting from the architecture. As I was saying, the M7 on the STM side is delegate to keep the communication through RPC between the M4 and the Linux side, so on the IMX8. We wrote the firmware that basically acts as a remote procedure call. So in order to make this the two cores, the two chips communicating on the Arduino side, you can just send the remote procedure call, and on the M7 it will be routed to the NXP chip, and on the NXP chip side, using message pack communication protocol, we do provide the communication with all the cores. So on the Linux side, you can use your preferred language. We provide examples in Python, but of course, there's implementation for any kind of language. I would say I'm pretty sure that there's 5 to 6 different programming languages available for a message pack to combine and to be combined and get these readings out from the STM core. The other question was if I can add some low power management system on the Linux side and then wake up from the STM. Yes, it's possible. Also on the Portenta X8, that is another board that we have. The same philosophy and approach is here for the X8, so the core can wake up the Linux side.
Cool. So all of the cores on one of the chips can access all the peripherals on that chip and all the local resource on that chip, but not on the other chip. They can only access things on their own device. Is that right?
Yes, they are basically
via a remote procedure call.
Yeah, the idea is that everything that should be in real time, so anything that's local to the bus, to the field, is meant to be done on the Arduino side, so on the STM. So everything is attached there, but with the RPC are visible on the Linux side.
Okay. So somebody says, is it possible to connect the X8 board to standard industrial field buses, such as EtherCAT and Profinet? And have you already done tests in this direction so far?
Okay. On a physical standpoint, yes, with of course with the custom carrier or whatever it is needed for connecting physically the device to the different field bus. On the Max carrier, we do provide some of them. We provide CAN bus. We provide mod bus that are basically one of the most used, I would say, or at least that we saw and companies asked us. But of course, yes, if there's a board that communicates with the X8 and provide the Profinet, for example, on the Arduino side, you can make your reads and then use it on the Linux side, or if you just need to manipulate or getting data from the field bus and then sending to the X8, it's quite straightforward. I'm on the Linux side. I'm not sure we have right now still some ready to be used on the Profinet example, but you know, there's a lot of things and software outside that can be used. Yes, at least if works on the container, So it's already made for Arch64. Can be used on a container to test.
Okay, another question, quick one. Can we install Windows embedded on Portenta?
Never tried. But if someone wants, I would be happy to report that it's working or not.
Okay, cool. What is the power consumption of the board, and can the Linux part be put into sleep mode? I think we already answered that.
Yeah, exactly. The exact power consumption, there's a data sheet because I don't remember right now. But yes, can be put in low power mode. Yeah, both on STM and the Linux side.
Okay, this one's a bit of a tricky one. All right, hold tight. So usually industrial systems are isolated from direct connection to the internet according to ISA 95 model, segmentation of network levels. How do you reconcile that with the automatic update of the OS via the cloud?
Good question. There are multiple ways right now. The updates, OTAs, and security updates are on geographical side. So on the geographical standpoint, so every board can act individually. So connect to the cloud, connect to the internet. But it's not the first time that companies are asking for this kind of different ways. So having, for example, a local gateway that provides the communication and the updates to the local board. So it's something that we are working on. Because we have been asked many times for this. So right now is working on a geographical point of view, and think about that when we do provide the OTA, so the entire fleet management is done in a way that is called factory. So factory is a virtual group of devices. So every device that is into this virtual group can benefit of the OTA, so secure and secure updates. Everything is based on a registry base. So think about Docker, how it works. Basically, there's a registry, so-called the registry, that basically provides all the information for the update. If we can push the registry local to a board that it's set up as master, all the other boards that are locally connected on the same network should be able to get the updates from that board. It's something that it's technically doable. We are working on because was requested.
Cool. So many questions to choose from, to be honest. Can the X8 Wi-Fi and Bluetooth be used simultaneously? I have a use case where I must consolidate data from multiple BLE devices and forward via Wi-Fi.
Technically speaking, can be done, but we have only one antenna, so there must be a little bit time differences between the usage of the Wi-Fi and the Bluetooth.
Okay, interesting. One just came in that's of interest to me. How does AI, artificial intelligence, apply to the X8?
The artificial intelligence can be applied in different ways. Of course, we have a really powerful machine at the edge, so you can have your model running on the X8. The training, of course, is made somewhere else because of the power needed for computational power needed for training the model. But you can use the board for getting data from the field to your preferred AI and machine learning tool or software. If you have tiny machine learning that you want to run locally, if you have an external systems like naming Edge Impulse or Pixel or any other that doesn't came in my mind right now, you can use the port to send data for get the machine learning, and then you can have the inference model back to the board. So if you have your own model, or if you have your code written in Python, you can have your own container, and you can pack everything on that container, having running locally on the X8. So there are multiple ways of approaching the machine learning. So in this case, the difference is between a pure embedded microcontroller. So the first example is the H7, where you have the same STM32 dual core. So in that case, it's pure embedded. Wow,
I have
that's
one.
perfect. Exactly that one. And so in that case, of course, you need to have inference model coming from an external service. In this case, you have Linux, so you can use both. You can have your inference file working on the STM32, for example. This is another example. And on the Linux side, you can have another ML working at the same time. So really, there's with this hybrid approach of having two hearts, meaning the Arduino core and the Linux core, you can really mix and match different ways to solve the problems, or approach different problems.
Okay, it was running short of time, but lots of questions. Is there any plan to have support of the X8 with Balena? And you'll have to explain Balena. I've not heard that one before.
Balena, yes, we are talking with them, and I think that probably in the next future we will see the board supported.
Okay, and then there was a question that I was just, oh, can the Potentia be used in additive manufacturing like 3D printing technology? I think
Yes.
I can answer that. Yes.
I would say absolutely yes. For 3D printer, we had boards, starting from the Mega, the Due, so back in times, and of course with the X8 you can have a more powerful, really more powerful Mega and Due on steroids. So yes.
I would think with the X8 you could actually control an entire room of 3D printers.
Not one, but probably 30 of them.
Yeah, amazing. I tell you, it just blows me away. How things have developed. Okay, we are running short of time, so I think we've got time for one more question. And as I said, any unanswered questions, Andrea will answer via email with the address that you provided when you registered. While I ask this last question, Andrea has told me you can feel free to contact him directly using the email address on your screen. So actually, there's two that I've gathered together out of the ones that have come in. What is the cost of the dev kit? And do you have a cellular version of the dev kit? And just to show I was paying attention, during the talk, you did say that there is a Potentia M1/NB GNSS shield, which I guess that would provide cellular capability. But don't let me answer for you, Andrea. Off you.
Okay, great. So yes, so the development board, if we think about the Portenta Max Carrier, is around $300. We just recently launched, so I think that it's available. Just me double check. Yes, it's available both on the US and Europe. So the Max Carrier is the first one. On the Max Carrier. So sorry, we have cellular connectivity, narrowband, and Cat-M1. If you need to add more, LTE, pure LTE, LTE 4, 5, whatever it is, if it's available, if it's in the market, you can use a mini PCI Express card that you can plug on the Max Carrier. And of course, you can also use the Portenta breakout board, that it's more easier. It's more useful for a local connection, because we don't have we don't have the mini PCI Express. But thinking about the Max Carrier, you have already in there the Cat-M1, narrowband IoT, LoRa connectivity, and then the opportunity to expand it by using the mini PCI Express connector.
Awesome. Well, thanks so much, Andrea. That was a very, very interesting presentation. Really appreciate it. I'm afraid that brings today's webinar to a close. We have run a little bit over, so I'm sorry for anyone who had something to do but decided to stay. Well, I'm happy you decided to stay. I'd like to thank everyone for attending and give a special thanks to Arduino Pro for their sponsorship, and especially, of course, to Andrea for his insightful presentation. Once again, this is Clive Maxfield, and I'm very pleased to have been your host for today's event. I look forward to seeing you all here again on the next IoT Central webinar. And until then, from all of us here at IoT Central, we hope that you have a wonderful rest of your day.
Thank you.